All right, in this video, we're going to go over rate of change. All right, rate of change. What is rate of change? Well, here's the definition. The average rate of change of a function, so let x1 comma f of x1, remember, f of x is just your y value, so this is x1, y1, and x2, f of x2, x2, y2, be distinct points on a graph of a function f. So here we go. Here's x1, here's x2. The y value here of f is f of x1, the y value here is f of x2. The average rate of change of f from x1 to x2 denoted by delta y over delta x. And that's the way you write it, say it, delta y, delta x. Or it's also the change in y divided by the change in x. Okay, there's two ways to say it. You'll probably hear me say delta y, delta x a lot. So delta y, delta x equals f of x2 or y2 minus f of x1 or y1 divided by x2 minus x1. All right, and we know that delta y over delta x, that's also just the slope of a line, right? y2 minus y1 over x2 minus x1. So basically, this is a fancy way to say what's the slope of the line between x1 and x2. Fancy way to say it. But that's all we're doing is finding the slope of the line between x1 and x2. All right? That's all we're doing. So let's look at a problem here. I got some graph paper. All right, let's look at the function f of x equals x squared. All right, we know what that looks like. We know if we put in 0, we get out 0. Put in 1, we get out 1. Put in 2, we get out 4. 1, 2, 3, 4. 3, we get out 9. 4, 5, 6, 7, 8, 9. And then, of course, it mirrors over the axes. All right, so here's our graph. Connect with a smooth curve. There we go. That's not too bad for hand drawn. All right, so we want the average rate of change, all right, A, if x1 equals 0 and x2 equals 1. So what does that look like visually? Well, x2 is 0, so it's right here. x1 is 0, x2 is 1. So here is our line that we're going to find the slope of. Right, it's basically what we're going to do is find the slope of it. Well, if you notice, we know by looking at it that the slope of the line equals 1. M slope equals 1. But let's do it using the average rate of change. So delta y over delta x. All right, delta y. So we need f of x2. Well, that's simply the y value at x2. The y value at x2 is 1, minus the y value at x1, which is this point right here, which is 0, divided by x2, which is, delta x, which is x2 minus x1, 0. This simply comes out to 1 over 1, which is 1, which verifies what we said earlier. Based on just looking at the graph, we knew that that line had a slope of 1. All right. Let's go from 1 to 2. So here's x equals 1 and x equals 2. So let's do a B problem down here. x1 equals 1, x sub 2 equals 2. So our line now is going to look like this. All right. Let's find the average rate of change of f of x squared between x equals 1 and x equals 2. All right. So delta y over delta x. Well, we know the delta x, that's just going to be 2 minus 1, which is 1. Because remember, this is just x2 minus x1. Right? That's what you saw in the other slide here. Delta x is just x2 minus x1. Delta y is essentially y2 minus y1. All right. Now, what is our y2? Well, we go to 2, we go up to the graph, we see that our y2 is 4 minus, and then at 1, our y2 is 1. 4 minus 1 is 3. 3 over 1 equals 3. And if you do look here, we go over 1, we go up 3, over 1, so that verifies. So average rate of change is simply the slope of your line between your two x values. And you just do y2 minus y1 over x2 minus x1. That's all you got to do. That's it for average rate of change. I mean, I could show you more problems, but it's not really going to change. You just figure out what your two x's are. Okay, well, they'll give you the two x's. From the two x's, you figure out what your y values are. Y2 minus y1 over x2 minus x1. Divide it out and write it in simplest form. Now, if this needs to stay a fraction, say 3 over 2, just leave it as 3 over 2. Don't give me a mixed number or a decimal. Just leave it as 3 over 2, because slope as an improper fraction means more than a mixed number or a decimal. All right? It means it has more value, and it's easier to use because then you can easily see, like if this was 3 over 2 and I said it was 1/2, they'd be like, well, what does that mean? Well, 3 over 2, you know, you go up 3 over 2. Okay, so leave slopes as fractions, even improper fractions. Don't change them to mixed numbers or decimals, okay? All right, now let's take average rate of change one step further and talk about the average velocity of an object. So here's the definition of average velocity. Suppose that a function expresses an object's position s of t in terms of time t. The average velocity of an object from t1 to t2 is delta s, which is your speed, your position. So you have s of t2 minus s of t1 over delta t, which is t2 minus t1. If you notice, this is the same thing that we had before. Same exact thing we had before, just with different variables. So they'll give you the time. They'll give you t1 and t2. They'll give you the time. They'll give you an equation. When you put in t1 into the equation, what you get out is s of t1. You put in t2 into the equation, what you get out is s of t2. It's that simple. Couldn't be much simpler than that, okay? That's all you got to do. So, let's look at a problem here with average velocity. Let me change colors. Let me go to orange. Now, just because I'm switching to orange does not mean I'm a Gator fan. I'm not a Gator fan. All right. So, say our equation is s of t equals 5t squared. The question says, the distance s of t in feet traveled by a ball rolling down a ramp is given by this function, where t is time in seconds after the ball is released. Find the average velocity from a t sub 1 equals 2 and t sub 2 equals 3. So we want to find the average velocity of the ball rolling down the ramp from 2 seconds to 3 seconds. Okay? So we know we need delta s over delta t. Well, we know that delta t is simply 3 minus 2 because it's t2 minus t1. So we know that's 1. Now all we have to do is find delta s, which is s of t2. So we take t2, which is 3, and plug it in here. We get 3 squared, which is 9, times 5, which is 45, minus, plug in a 2. 2 squared is 4. 4 times 5 is 20. 45 minus 20 is 25. So the average velocity of the ball is 25 feet per second. Okay? 25 feet per second, because that was the units from the problem. I know I didn't show you the problem, but make sure you bring your units down. If this was meters per minute, this would say m over min. All right? But it says that the ball is rolling in seconds, and it wants to know how many feet it traveled, or the average velocity in feet per second is what that means. All right? Let's look at another one. I want you to do this one. I'm going to give you some time to do this one. Actually, I'm not. Pause the video when I get this written down and do it. Do it from t equals 2 to t equals 2.5 seconds. Okay? 2 seconds to 2.5 seconds. Pause the video and figure this one out. All right, so we have to find delta t, delta s over delta t. Easiest thing to do is delta t. 2.5 minus 2, that equals 0.5. Now, we have to plug these in to our function, our original function, to figure it out. Well, we know what 2 is because we did 2 earlier. When you plug in a 2, you get 20 because 2 squared is 4. 4 times 5 is 20, so this is going to be a minus 20. Now, you got to plug in the 2.5. Okay? So when you plug in the 2.5 to here, you get 2.5 squared, which is 6.25, times 5, which is 31.25. All right? Don't believe me? Verify it. So we have 31.25 minus 20 over 2.25 minus 2. When you subtract this out, you get 11.25. Okay? 11.25. 11.25 divided by 0.5, which is basically you're multiplying this by 2. You get 22.5 feet per second. Because remember, dividing by a half is the same thing as multiplying by 2. All right? So there you have 22.5 feet per second. All right, I'm going to make you try one more. Oops, I don't know why I put that division bar. Make you try one more, and then we're going to call this video a wrap. All right, let's go from 2 to 2.01. Figure that one out. Pause the video and go for it. All right, we need to do delta S over delta T, so 2.01 minus 2 equals 0.01. And now we got to plug in the 2.01. When you plug in the 2.01, you should get 20.005. I'm sorry, 20.2005. Sorry about that. And then when you plug in the 2, you get minus 20. So when you subtract those two, you get 0.2005 on the top. And when you do your division, you are going to get 20.05 feet per second. Hopefully you got that. All right. So just again, all you do for average velocity, like we were doing, you do delta S, which is S of T2 minus S of T1, and delta T divided by delta T, which is T2 minus T1. And again, to get S of T2, you simply take your value for T2, plug it into whatever function they give you. To get S of T1, you take T1 and plug it into whichever function they give you and do this subtraction. And then the division. Average rate of change, pretty much the same thing. You're just basically finding the slope of the line between 2 points. X2 and X1 are those 2 points. F of X2 and F of X1 are simply the Y values of those 2 points. All right? So that's it for rate of change. Make sure you understand the concepts in this video and come to class tomorrow ready to work some problems. See you tomorrow.